Algebra, Unit 3, Lesson 1, Graphing Linear Equations, Video 1, Standard Form. A linear equation is an equation that forms a line when it's graphed. Linear equations are often written in the form of ax plus by equals c. This is called the standard form of a linear equation. It follows alphabetical order. In this equation, c is called a constant or a number. Ax and by are variable terms, again, following alphabetical order. Key concept. The standard form of a linear equation is ax plus by equals c, where a is greater than or equal to 0, a and b are both not 0, and a, b, and c are all integers, so positive, negative numbers are 0, with a greatest common factor of 1. So, no decimals, no fractions, and there cannot be a greatest common factor larger than 1. So an example of this could be 3x plus 2y equals 5, or x equals negative 7. So as we slide down, let's look at letter A. Determine whether each equation is a linear equation. Write the equation in standard form. So I need this to look like ax plus by equals c, following the rules above. No decimals, no fractions, no greatest common factor larger than 1. So, first thing I notice about A is I have a fraction. I also notice that x and y are not on the same side. So it doesn't always really matter what you're doing first. I might just say, okay, the fraction is the scariest part. I'm going to get rid of that. Okay, so the way to get rid of a fraction is we can we can do anything to an equation as long as we do it to both sides. So if I'm dividing by 4, I'm going to multiply this whole thing by 4. Again, I can do whatever I want as long as I do it to both sides. So I'm almost going to distribute multiplication of 4 to everything in here. All right, 4 times 3/4 is 3x. All right, make that a little neater for you. 3x equals 4y plus 32. So I just multiply by 4 and all of a sudden the fraction's gone. Great. Now, we need that y to be on the same side as the x. So I'm going to subtract 4y from both sides. So my equation is 3x. Again, alphabetical order A first. 3x minus 4y equals 32. Now, I have ax minus by equals c. So this is in standard form. Is this a linear equation? Would this make a straight line if I graphed it? Yes, there's a constant rate of change. Yep, of course. Please try letter B on your own. We're going to slide down to letter C. All right, letter C. Y equals x squared minus 4. We have never had x squared for linear. This is nonlinear. If I wanted to make sure, I could pull out my graphing calculator and type that in. If I do that, I would get something that looks like this letter U, called a parabola, and that's nonlinear. If we slide over to letter D, we'll do this one together as well. This time I don't have an x, which again is okay. But I still have a fraction, so let's get rid of that. I'm going to multiply this time everything by 3 to get rid of the denominator. If I then distribute that, I'm going to get y equals negative 3. That is in standard form. There is no x. A would be 0, b would be 1, and c would be negative 3. So that's the equation in standard form. And is this linear? Yes, it is. It would make a straight horizontal line on a graph. Please try letter E and F on your own. Remember, the greatest common factor can be nothing greater than 1. There could be no decimals, no fractions. AX plus BY equals C. On the back, intercepts. A linear equation can be represented on a coordinate graph. The x-coordinate of the point at which the graph of an equation crosses the x-axis is the x-intercept. The y-coordinate of the point at which the graph crosses the y-axis is called the y-intercept. We've been working with y-intercepts. The difference is we're not only now going to talk about where the line crosses the y-axis, but also the x-axis. The graph of a linear equation has at most one x-intercept and one y-intercept, unless it's the equation x equals 0 or y equals 0, in which case every number is a x-intercept and y-intercept respectively. To find the x-intercept, make the y value 0. Similarly, to find the y-intercept, make the x value 0. Find the x and y intercepts of the graph. So letter A, this is the y-intercept. The point where this line crosses the y-axis is the y-intercept. This is the x-intercept. The point where this line crosses the x-axis, the x-intercept. So if I was looking for this, I would want to make the y 0 to find y, where y is 0, that would give me the x-intercept. To find where the x is 0 would give us the y-intercept. So for this, letter A, it just says find the x and y-intercepts of the graph. Okay, so we should put those as ordered pairs. So the x-intercept and the y-intercept. So the x-intercept is located at 4, 0. So again, we made the y value 0 to get the x-intercept. And then the opposite, where is x 0? Here. So at that point is where y is 200. That's the y-intercept. So 0, 200. Please try letter B on your own. Letter C. A box of peanuts is poured into bags at the rate of 4 ounces per second. The table shows the function relating the weight of peanuts in the box and the time in seconds the peanuts have been pouring out of the box. Find the x and y intercepts. Describe what the intercepts mean in the situation. So that's a big important piece, in the situation. So that means tell me in English, not in math. Tell me what is happening at those 2 points. Okay, so I can look at the table of values. When x is 0, that's the y-intercept. When y is 0, that's the x-intercept. I can also see them right here. There's the y-intercept and here's the x-intercept. So with very little work, I can find those. So we need to find them, done, but now describe them in words. So we're going to need to almost talk about writing not a paragraph, but a couple of sentences. Describe what they mean. All right, as we look across the coordinate plane, we come across the y-intercept first. So I'm going to start with that. The y-intercept, which again, where x is 0, is 2,000. Okay, so now what does that mean? That means that, again, we're talking about pouring peanuts. So at time 0, the box weighed 2,000 ounces. We can't say times 0, so what does that mean? At the beginning, something of that nature. So the y-intercept, 0, 2,000, represents let's say, the box weighed 2,000 ounces before it started to be emptied. Then the x-intercept, and that's at 500, represents that it took 500, and the x-axis is labeled in seconds, so it took 500 seconds for the box to be emptied, or a 0y. And that's all that we need to say. So it's not a paragraph, it's a couple sentences. We mentioned, we found both the x and y intercepts, we listed those, but then we described again in ELA what those actually mean. If you could do letter D on your own, remember to find both the x and y intercepts, but then of course in ELA tell me about the situation. What did they actually mean in words? All right, on the next page, graph linear functions. By first finding the x and y intercepts, you have the ordered pairs of 2 points through which the graph of a linear equation passes. Okay, so we're going to do the same thing, find the x and y intercepts, and use those then to graph the linear functions. This information can be used to graph the line because only 2 points are needed to graph a line. Now, I always tell you a minimum of 3, so that you're sure you know your slope, you're sure you know your line. However, if you're using the intercepts, you really only need 2. So if you find those correctly, that is enough. So, letter A, graph each equation by using the intercepts. Okay, so on the first couple pages of these notes, we had said the x-intercept is where y is 0, and the y-intercept is where x is 0. So I'm going to find the x-intercept first just because it's first in the alphabet. So the x-intercept is found when y is 0. So I'm really just going to substitute a 0 in for y and solve. So let's see, I get negative x plus 2 times 0, well that's 0, so plus 0 is still negative x equals 3. Now that I have a negative x, so I'm going to divide both sides by negative 1. So I get x equals negative 3. So my x-intercept is where x is negative 3 and y is 0. Now I'm going to do the same thing for y. So I'm going to start from the beginning, negative x plus 2y equals 3. The y-intercept is found when x is 0. So I'm going to plug in a 0 for x and solve for y. Okay, so negative 0 is 0, so this is just 2y equals 3. I don't care what 2y is, I need to know what 1y is, so I'm going to divide both sides by 2. So I get y equals 3 halves. When graphing, improper fractions aren't always easy, so maybe we want to say that instead, that the y-intercept is 0. Okay, 3 over 2 is 1.5. That might be easier than 3 halves. Alright, so let's plot those. Our x-intercept is negative 3, 0, so I'm going to go negative 3, 0, best I can with this. It's right there. Alright, and then I want to do 0, 1.5. So 0, 1.5 is about there. So now I need to connect those with a straight line. So on your worksheet, you better have a ruler out. Your line better pass clearly through those 2 points, and you need to have an arrowhead on both sides. Alright, so pull out your ruler, connect those the best that you can. There we are. And remember that there should be an arrowhead again on both sides. And then we are finished. I would like for you to try letter B on your own. Letter C. Okay, so I'm going to go back and make my table of values like I did back in 6th grade. It should have 3 columns. We should have x, we should have the rule or the equation, and then our y value. So for this, with the origins in the center, so I can pretty much use any values. For x, usually it's better to think of some positive numbers, so let's just do 0, 1, 2, 3, and see if that works for us. If not, we can save room for a negative. So let's say 0. So wherever we see an x, we're going to plug in 0. So 2 times x, 2 times 0 is 0. So this really says 0 minus y equals 2. Well, what value of y will make that true? So negative 2 is our only option. Alright, let's try x as 1. So 2 times 1 is 2 minus y equals 2. What will make that true? 2 minus something is 2, only 0. Let's try 4 minus y equals 2. So 4 minus what will give us 2 is 2. And 6 minus y equals 2. So 6 minus 4. So the 2 values that we actually need are the x and y intercepts, which we found right here. There may be some guessing and checking involved if you don't find those this quickly or that easily. And again, that's alright. You can use the table to go as big or as long as you want. So our first point is 0, negative 2. So 0, negative 2 is right about here. And our second point is 1, 0, which is right about here. So again, we're going to need to get out our ruler. and connect those the best that we can with a straight line. Do not be lazy. And again, we're going to need some arrowheads on both ends. And that's how we graph using the table. I would like you to try letter D on your own. That one hopefully is a little bit easy after you have to think about it for a little bit.